Alright, this is the review for the equations unit, unit 1 for algebra 1. So if we start number 1, a couple ways we can go about this. I'm going to start, since I have this 5 out front that's being multiplied, instead of distributing, I'm going to divide the entire equation by 5. So I'm going to divide the left side by 5 and the right side by 5 to get y over 10 plus 0.3 is equal to 5. That was the division property of equality. Then our next step is to get the y by itself, so we're going to subtract 0.3 from each side. So y over 10 is now equal to 4.7, and that was the subtraction property of equality. We need to make sure we show our justification on each step. And my last step is to multiply both sides by 10, get the 10s to cancel. Y is equal to 47, and that's the multiplication property of equality. Number 2, same idea. I have this negative out front. So the way we're going to get rid of that negative out front is it's going to get distributed into the original problem. So that becomes 3x minus 2 equals positive 13. And then we're just going to solve the rest of it from there. So plus 2 to each side. 3x is equal to 15. Divide both sides by 3. X is equal to 5. And my 3 steps were distributive property, addition property of equality, and division property of equality. Moving on to number 3, solving negative 1/2 x is equal to 50. So this is a multiplication problem because it's negative 1/2 times x. So the way we undo multiplication is with division, or in the case of a fraction, we can multiply by the reciprocal, which would be negative 2 over 1. Make sure we multiply that to both sides. So the fraction cancels out. We get x equals 50 times negative 2, which is negative 100. Number 4, start by subtracting 5 to both sides. 10 is equal to negative 2x. Divide by negative 2 on both sides. Negative 5 is equal to x. Number 5, we have variables on both sides, so we're going to move one of them. We talked in class about always moving the smaller one, which in this case is going to be the negative 2x. So we have 5 is equal to 15 plus x. Subtract the 15 from both sides, get the variable by itself, and we get negative 10 is equal to x. Number 6, this is kind of a big problem, but we're still going to follow our regular steps. Remember from class we talked about the order of operations that we use is distributive property, combine like terms, variables on both sides, then we do the constant, then the coefficient. So that's the order that we're going to follow. So we have distributing, distributing, distributing. So we get 3x minus 6 minus 2x minus 6 is equal to 125 plus half of 4x is 2x and half of negative 8 is negative 4. So that was distributive property. Next, we're going to combine like terms. So the 3x and the negative 2x are like terms. The negative 6's are like terms. And on the right-hand side, we have the 125 and the negative 4 are like terms. So if we combine those, 3x's minus 2x's is x. Negative 6 and negative 6 is negative 12. That's equal to 125 minus 4 is 121 plus 2x. That was combined like terms. Then this is just like problem number 5 at this point. So we are going to move the smaller variable. So I'm going to subtract x from both sides. Negative 12 is equal to 121 plus x. Subtract the 121 from both sides. Negative 133 is equal to x. and now that's all done. So my last two steps were variables on both sides, which was really the subtraction property of equality because I subtracted the x. Then I did the subtraction property of equality again, and then I was all done. Alright, number 7. So 7 through just about the end of the test, we have to set up an equation and then solve it. So 7 says the width of a rectangle is 1/3 its length. The perimeter is 72. Write an equation to determine the width. So if we draw a picture, there's my rectangle. I have my length, and then my two widths are these two sides. But I know that the width is 1/3 whatever the length is. So I get that. So the perimeter of the whole shape is length plus 1/3 the length plus 1/3 the length. The perimeter, we're told, is 72. So 72 equals L plus 1/3 L plus 1/3 L. So we can combine like terms and get, I'm going to do this in two steps, 2L plus 2/3 L. I can combine those now. 2L's plus 2/3 L's is 8/3 L. So I have 72 is equal to 8/3 L. To get rid of the fraction, we're going to multiply by 3 over 8 on both sides. So these cancel out. 3/8 times 72 gives me 27. That's the length, but the question asks for the width. Well, we know that the width was 1/3 the length. So the width is 1/3 the length, which means the width is 1/3 times 27. 27 times 1/3 gives me 9. So the width of the rectangle is 9 inches. Width is 9 inches. Alright, number 8. Zuzu's salary is 3/4 of Paul's salary. Together they earn $1,323 a month. Write an equation, then determine Zuzu's salary. So this is going to be very similar. If we say that P is Paul's salary, remember we need to define our variables. P is Paul's salary, then their combined salary is Paul's salary plus Zuzu's, which Zuzu is 3/4 of whatever Paul gets. And together, when we add them, we get 1,323. Just to show you a different way to do it, because we have a fraction, we talked about in class that we could clear the fraction by multiplying everything by that denominator, and we can distribute. So we have 4p plus 3p equals 1,323 times 4, which is 5,292. Combine our like terms. 7p is equal to 5,292 divided by 7. P is equal to 756. That's Paul's salary, but again we're finding Zuzu's salary, and we know that Zuzu's salary is 3/4 of whatever Paul gets. So Zuzu gets 3/4 of 756, which means she gets a total of 567. So Zuzu's salary is $567. Number 9. Driving to Flagstaff from school. In the first hour you travel 3/4 of the total distance. The second hour you travel the rest of the distance, which is 55 miles. Write an equation to determine the total distance you drove. So again, we're going to set up an equation. We need to define a variable. I'm going to say that d is the total distance. So let's see, so the total distance is equal to 3/4 of the distance that you drove in the first hour plus the other 55 miles. So we have that common variable of 3/4 of the distance plus the other 55 is equal to the total distance. So again, I don't want to deal with those fractions. We do not like them. So we're going to multiply everything by 4 so we get distributed. So 4d is equal to 3d plus 55 times 4, which is 220. We're going to subtract the 3d from both sides. So d is equal to 220. So the total distance is 220 miles. Don't forget, since these are word problems, we need to write it in context. We need to write down what we just found. Number 10, we're going to skip it. The question is worded poorly, and we're missing some information to get the full solution. So don't worry about number 10. Number 11, Maria is buying a new laptop at Best Buy. The laptop is on sale for 2/3 the original price. She uses a $50 gift card, and the total cost before tax is $350. Write an equation, and then find the original price of the laptop. So again, set up a variable. I'm going to say that P is the price. So if it's on sale, we're paying for 2/3 of the price plus, it's actually not going to be plus because it says after she uses a $50 $50 gift card. So it's 2/3 the price minus the $50 for the gift card. That leaves her paying for $350 for the laptop. So 2/3 P minus 50 equals 350. This time I'm going to add the 50 to both sides. It doesn't really matter which way we do it. We can multiply everything by 3 first. Just personal preference. So 2/3 P is equal to 400. Now to get rid of that, to solve for P, we're going to multiply by the reciprocal, 3/2. So P is equal to 600. So she paid, she only paid 350, but the original price of the laptop was $600. Alright, Susie's renting a car and the rental company is charging $150 per week. They also charge 3 cents per mile. If she can only spend $200, how many miles can she drive in 1 week? So again, set it up. The only variable that we have is miles. So M is the number of miles because we're told she's driving for 1 week. So I know up here it says it's 150 per week, which makes it seem like that would be like 150 times a variable. But we're told that it's for exactly 1 week. So we don't need to worry about 150 times anything. It's just going to be 150 times 1, which is 150. So her total charges for the week are the $150 to rent it plus the 3 cents per mile. And she can spend, that has to be equal to $200. So we solve this by subtracting the 150 from both sides. 0.03 M is equal to 50 divided by 0.03. Use a calculator for that part. 50 divided by 0.03 is 1,666.6. Repeating. Since we're driving miles, we're going to assume that she has to drive whole miles, or at least the company is going to charge her by the complete mile. So 1,667 miles would be too much. She would pay too much because she can only spend 200. So we're going to round this down to she can drive 1,666 miles. Alright, 13. Lawrence's parents, so 13 through 15, same idea as the previous problems, except for we're going to have 2 variables now. It's going to be equal to something that we don't know. So we're going to set up an equation that has 2 variables, then we're going to deal with it later. So Lawrence's parents pay him a base allowance of $20 per week and $3.55 per hour for extra chores. Part A, write an equation that models Lawrence's total weekly income. So we've got two variables. I'm going to call H is the number of hours and T is the total income. So his total income is equal to the $20 that he gets just for being a nice guy plus $3.55 per hour. There's my equation for his total income. And then for part B, here's your equation. Evaluate the total amount of money he can make if he does 7 hours of chores. Well, all I have to do is plug the 7 in for H. So T is equal to 20 plus 3.55 times 7. Use our calculator. We're going to get 20 plus 2485. We add those together. T is equal to 4485. So he makes $44.85 for doing 7 hours of work. 14. Verizon charges $10 for 100 texts. Every text over 100 costs 10 cents per text. Write an equation to model this. So I'm going to say C is the cost. T is the number of texts. What we need to be careful is the texts after the first 100. Actually, we're just going to call it text and we'll deal with the 100 later. Okay. So write an equation to represent this scenario. So C is the total cost. So the cost is $10 for the first 100 texts plus 10 cents. And normally we would just think that it's 10 cents times T. But because we only pay the 10 cents after the first 100, means we have to subtract the first 100 texts out of there. So if you think about it, how you would actually be paying if you sent 102 texts, you're only paying 10 cents on those last two because the first 100 were included. So the way we handle that is we actually do T minus 100, and that's all grouped together in parentheses so that we have $10 plus 10 cents times the number of texts we send after the first 100. Part B is use that equation to evaluate the total amount of money Verizon will charge if you send 1,200 texts. So C is equal to 10 plus 0.10 times 1,200 minus 100. So this is exactly what I was talking about just a second ago. That we sent 1,200 texts, but we're only paying the 10 cents on 1,100 of them, which we're going to see right there. So C is equal to $10 plus the 10 cents times the 1,100 extra texts. So 10 plus 1,100 times 0.1 is 110. So C is equal to 120. So it will cost $120. 15. Swap Meet charges $20 per day to rent a space, plus a one-time application fee of $5. Assume you rent a spot at Swap Meet for at least 1 day. Write the equation for the total Swap Meet charges, where D is the number of days the space is used. So this one actually defined the variables for us. It told us that C was the cost and D was the number of days. So the equation, the total cost, is equal to, it's $20 per day, so that's 20D, plus $5 extra just to rent the space, or for the application. There's my equation. Part B, use your equation to evaluate the total charges if you rent the Swap Meet space for 8 days. So C is equal to 20 times 8 plus 5, so that's 160 plus 5, so that's $165. It will cost $165. Alright, part 4, CEDA4. These are the literal equations where we're solving for variables. So remember at the end of the sentence here where it says 4b, 4h, 4y, that means you're solving so that your final answer is going to say b equals, or it's going to say h equals, or it's going to say y equals. So we're getting that variable by itself. So we look at number 16. Here's our variable, so we move everything away from it, so we subtract the 10. So we subtract the 10, we get y minus 10 is equal to 5/8 b. So then to get rid of the 5/8, we're going to go ahead and multiply by the reciprocal, which is 8/5. This whole thing is multiplied by 8/5. Those cancel. And because this 8/5 is not going to go evenly into the other side, I'm going to leave it just like that. 8/5 times y minus 10 is equal to b. And that's all done. 17. We have the formula for the area of a trapezoid, and we're solving for the height. Now we notice that the height is this guy way over here by itself. b1 plus b2 over 2 times h. So we want to get rid of everything except for this h. Well, everything else is this fraction that's being multiplied to h. So how do we get rid of a fraction that's being multiplied? We multiply by the reciprocal. 2 over b1 plus b2, 2 over b1 plus b2. These cancel out, and we're left with 2 times a, because remember that's going to be a over 1, so it's 2a over b1 plus b2 equals h. We're all done. 18, solve for y. Same idea, here's our y. Get rid of everything else that's not a y, so we're going to subtract the 3x. So we have negative 15 minus 3x is equal to 6y. Divide everything by 6. So we have negative 15 over 6. When we reduce that, we're going to get negative 5 over 2 because we divided everything by 3. And then negative 3 over 6 is negative 1/2 x, and that's equal to y. 19. The area of a rectangle is 56.8 square inches. Write an equation to represent the situation using length and width. So area of a rectangle is length times width. So if we plug in what we know the area is 56.8. That's equal to length times width. That's done for part A. Part B, rewrite the equation in terms of the width. So I'm going to solve this equation for W. To solve it for W, divide by W on both sides. Oops, sorry, not divide by W. We want to, because we're solving for W, so we want to divide by L. Those cancel. W is equal to 56.8 over L. Part C, what is the width of the rectangle if the length is 10.2? So we're going to just plug in what we know. W is equal to 56.8 over 10.2. This is the whole reason why we use this method, is because in the other one we would have to plug it into the multiplication side, then divide anyway. So if we already have it written this way, it's already divided. Use our calculator. 56.8 divided by 10.2, and the width gives us 5.6 inches. Alright, and finally the last page. Absolute value equations. Remember, when we have absolute value equations, we're going to have two cases. We need to check our solutions to make sure all the cases work out correctly. And our first step is always isolate the absolute value bars. So when I look at the first one, negative 3 times the absolute value of g is equal to negative 15. To isolate the absolute value, I'm going to divide by negative 3 because these are being multiplied. Those cancel. Absolute value of g is equal to 5. This is where we make our two cases. Case 1 says g equals 5. Case 2, g equals negative 5. And there's nothing else to solve here, so there's my two solutions. And then to check the solutions, I take those two values and I plug them back in. So negative 3 times the absolute value of 5 equals negative 15. Absolute value of 5 is 5, so this is 3 times 5 equals negative 15, which is true. Check the other case. Negative 3 times the absolute value of negative 5 should be negative 15. Absolute value of negative 5 is 5, so it's negative 3 times 5, which is negative 15. Negative 15 equals negative 15, also true. 21, we're solving this absolute value equation. Again, I've got this negative 5 out front, and then divide by negative 5 on both sides. Absolute value of x minus 9 is equal to negative 3, and I am finished, because absolute value means distance. This right now says the distance of something is negative 3. Distance can't be negative, so this has no solution. 22, solve and check. So one more time, I'm going to get the absolute value by itself. I'm going to move the minus 15 first. Sum up with 5 times the absolute value of x minus 25 is equal to 55. Divide both sides by 5 to cancel out the 5's. Absolute value of x minus 25 is equal to 11. Make my two cases. Case 1 is going to be x minus 25 is equal to 11. Case 2, x minus 25 is equal to negative 11. Add the 25 to both sides. X is equal to 36. And add the 25 to both sides. X is equal to 14. So x is 36 or 14. Alright, and we gotta still check those solutions, make sure we're all good. So we're gonna do that up here. So remember, our original equation was 5 times the absolute value of x minus 25 minus 15 equals 40. So if I check the 36, it's 5 times 36 minus 25 minus 15 equals 40. 36 minus 25 is 11. 5 times the absolute value of 11 minus 15 is 40. Absolute value of 11 is 11 times the 5 is 55 minus 15 is 40. 40 equals 40. That works. Check the second case. 5 times the absolute value of 14 minus 25 minus 15 equals 40. 14 minus 25 is negative 11. So plug that in. Absolute value of negative 11 is 11 times the 5 is 55 minus 15 is 40. And still 55 minus 15 is 40. So that worked. Last two problems. These are the word problems. When we read this, we're looking for maximum and minimum temperatures. Remember, what we used in class was it's the absolute value of the expected minus the actual, and that was equal to the variance or the tolerance, however we set it in class. Okay, so Captain Picard is heating up his Earl Grey tea. The proper brewing temperature is 210 degrees plus or minus 5 degrees. Write an equation to represent the situation. So absolute value, the expected temperature is 210 minus the actual temperature, which we don't know, so that's x, has to be equal to 5. So we have to be within 5 degrees. There's our equation. Second part, solve that. So we know when we solve absolute value equations, we have the two cases. 210 minus x equals 5. 210 minus x equals negative 5. subtract the 210. Negative x equals negative 205, so x is positive 205. And on the other side, minus the 210. Negative x equals negative 215, so x equals 215. When I compare those two numbers, obviously the 205 is the minimum, 215 is the maximum. 24. A machine's filling oatmeal containers with 32 ounces of oatmeal. After they're full, they get weighed. If the weight is not within half an ounce of the 32 ounces, the container is thrown out. So write an equation. So once again, it's the absolute value of the expected amount, which we expect it to weigh 32 ounces, minus the actual amount, which we don't know, has to be within half an ounce. So there's my equation. Solve the equation. 32 minus x equals 0.5. 32 minus x equals negative 0.5. Solve this by subtracting the 32. Negative x equals negative 31.5. So x is 31.5 ounces. And on the other side, subtract the 32. Negative x equals negative 32.5. So x equals 32.5 ounces. This is going to be our minimum. This is going to be our maximum. And that is it for the review of Unit 1.